Whereas the other two, say the nodding was maybe the X direction and this twisting maybe was the Z direction, then this XYZ rotation order would make sense to use. Okay, Bart, is that answering your question partially?
Yeah, maybe, but is it the only way to avoid gimbal lock?
The only way to avoid gimbal lock is to basically avoid rotating these things so that the axes line up. Now, that's the only way to 100% avoid it. There are ways to work around it, though. Okay, and I can show you some of that. So if you get into gimbal lock, there are things that you can do to, basically make it a better situation. So let's set some keys here. All right, so I'm going to set a key on that. Let's move it through space here. Okay, so and then let's do a rotation. So in this case, rotating in the X direction, so I'm giving it a few 100 degrees of rotation there, 970. That's too many. I don't need 970. Let's back it up. Just do 200 degrees. All right. So there's that. Now let's do this. Let's turn him. Now see what happens? If I want to try and rotate in the direction I was already going, I'm out of luck. If I'm using gimbal mode, okay, which is this. Now, using gimbal mode, again, can help you to avoid gimbal lock by actually letting you see when these two axes line up, and you can choose to avoid it that way. But if you're using a different manipulator, you're not going to see that. See, I'm in local mode now, which is usually, I think, what most people like to use is local mode. Now I can continue if I set a new keyframe here to rotate in that same direction I was going, but I'm using the outer ring now, or I could use the Y direction here, as it's depicted. But okay, so if this is my animation, now you can see what happens. See how it goes crazy in this little area here? It just goes crazy. Whereas here it rolled very nicely. So what this means, something got screwed up. And it's because you hit gimbal lock that it's starting to freak out. So what we have to do is we have to go to the rotations and we kind of have to figure it out. Now there's no way, unless you go frame by frame, that you're actually going to fix it on your own. So what they've done is they've created a tool called the Euler filter, or the Euler filter. And that's under curves. First of all, select the curves that you want to apply this filter to, which would be all of the rotations. And then go to the Euler filter and just click it. Now what it's done is it's done a mathematical computation that tries to give you the rotation you asked for, but by turning the axes in the best possible order. Okay, so let's see if it's any better here. Okay. Now see what happened though? It's not perfect. It's not a perfect solution, and it definitely isn't here because you can see that it's no longer rotating the way that we started it rotating. So that really didn't work very well. Now this is with a bouncing ball. If you're dealing with something like a hand or a leg or something like that, a lot of times your results will work out a lot better. It actually will give you something that you can use with the Euler filter. But in a case like this with just the ball, because it's so simple in terms of shape and figuring out the direction, what I would do if I was you would be to simply use the axes in such a way where you're going to avoid gimbal lock on your own. So in other words, use the gimbal mode and make sure that you're not hitting the thing you don't want to hit, the lining up of the axes. Okay, so where is it? It's not there? Where is it? Local? Oh, these are move settings. Hold on. Where's my rotation settings? There we go. Gimbal. Okay. So yeah, I mean, in this case, honestly, what you would do is, since you guys are all working in an orthographic view anyway, this would be very, very simple to avoid. All you have to do is position your ball when you start in such a way where you're not really going to have to use very much this rotation in the y direction. Okay, if this is our 2D picture plane and I'm using the rotate in the x direction, then I know I'll get the kind of rotation that I want, and I will never have to worry about gimbal lock. And if you want to rotate it in the other direction too, you can do that. You can do as much as you want with x and z. As long as you can avoid doing anything with y, you'll be a lot happier. Now, if you have to do the y direction, you can see that you can actually go close to 90 degrees in each direction, and you'll still have some control. It just won't be as good as if you tried to avoid using this altogether. Now there is another way to avoid this problem even better. Jacob Gardner talks about this in one of his classes. It involves creating a fourth axis. He actually has the code for it. I don't know what the code is. So if you want to check that out, just search. It was last workshop, and it was one of his classes from last workshop where I think it talks about the fourth axis. We call it an orbit. That's what they use at work. So if I just type here, just so you guys get an idea of what it looked like. At DreamWorks, they would have a channel called orbit, and then you would have your rotation in the x direction, your rotation in the y direction, your rotation in the z direction. And what orbit did was it carried all the other axes with it. Okay? It would just be like having a second rotation in the y direction. Does that make sense?
Yeah.
Sort of. I mean, you guys would have to experience it to really understand what I'm saying. But sort of, yeah. I mean, it's basically, you could almost replicate it by doing it this way. Like if we did, hold on, I want to undo some of this. Let's put these back to 0. Delete these back to 0. There. Okay. Let's say I group this to itself. Let's see if that works. Control G. Okay, so I've got a group 1. Upper ball control, I'm going to call it. Okay, so now if I look at my hierarchy, here's the baller rig. That's the global control. Ball geo. Where's the? Okay, here it is. Okay, so here's the original ball control. That's the squiggly line, right? That's the one all my rotations are on. Now if I look at the upper ball control, if I rotate this, that's the group that I just made. I can control the ball just the same way I could control it with just the straight up ball control, right? It essentially gives me another level of control over what I already have. So if I just said the only channel that I want to use here is the rotation in the y direction, so I'm just going to hide all these other channels. Oops, missed one. I selected. Okay, so for this upper ball control, all I have is a rotation in the y direction. Now, if I choose to say, well, I want to rotate the ball, I can turn it here where my axes are completely gimbal locked, right? But then if I go down a level to the next control, all its axes are completely fine. You know, they're still the way they were before. So if I split up the way that I want to control my object, if I split it into 2 nodes instead of just 1, that's another way to avoid gimbal lock. You know, basically, if I do all my rotations in the Y direction on this upper node, and I do all my other rotations on the lower node, then you could avoid it that way too. Does that make sense?
Yeah, but why does not every rig has such solution in it?
Because it's entirely up to the rigger. You know, if they're not going to put it in, then you're not going to have the control for it. And honestly, you know, depending on where you work, you may not have this flexibility in your controls. Not every rigger is as good as every other one, you know. And sometimes people are just used to struggling through things, and they just make it work. Like, and I worked for 5 years, I think, at Sony ImageWorks, and it wasn't until I got to DreamWorks that they even had this extra control. So I was fighting gimbal lock, you know, every single day when I was working at ImageWorks, and nobody ever thought anything of it. They're just, a lot of times they would say, well, use the Euler filter or use the Euler filter, and a lot of times it worked, but there were some times that it didn't. So, you know.
So why does this one axis behave this strangely?
Why does this behave strangely?
Yeah, always.
You mean what?
Is it just a math problem?
Yeah.
Well, no.
Sorry, it's basically the way these rotations are calculated. It all goes into some kind of a matrix. I don't know the math behind it, but I know that it goes into some kind of a matrix, and something goes haywire. I don't know what it is. But they've tried to create different calculations that would avoid this kind of thing. Like, I think there's something called a quaternion or something like that. It's a different way of doing these calculations, and I guess it gets better results in some cases. Like I said, some of these problems can be solved simply by being smart about your